Now the next topic for us in this chapter is blockchain technology. Now when it comes to blockchain, we are going to discuss the process of blockchain and we are going to discuss the basics of how blockchain is implemented. So first of all, what is the meaning of blockchain? You have two words here, block and chain. And what we basically mean here is that there will be blocks of information that will be connected via chains. This is basically what we mean. Now, the overall implementation is not really as simple as it sounds here. So there are a lot of things that are involved, but there are two very important properties when it comes to blockchain. These are one, decentralization, and second, immutability. So we will have to understand the meaning of immutability and decentralization, because these are two core concepts on the basis of which the blockchain entirely is executed. So first of all, what do we mean by blockchain? In very oversimplified terms, we are just talking about blocks of information that are connected to one another via chains. That's why blockchain. Now, what is the property about this blockchain which is making so much of news? Why are we looking at blockchains all over? All the cryptocurrencies, different kinds of cryptocurrencies, all these cryptocurrencies, they work on the principle of blockchain. But not only cryptocurrencies, there are other application areas as well which work on blockchain. For example, the healthcare sector can work on it, or the contracts can be made on it. And there are n number of ways where you would see that blockchain can be implemented, or blockchain can be very helpful in implementing a particular system. So first of all, we are looking at a decentralized distributed ledger that records the provenance of a digital asset. And that's why it is also known as distributed ledger technology, or DLT. So this name is given mainly because it is a distributed system, a decentralized system, and an immutable system. The meaning of immutability we'll try to understand. Now, what happens in blockchain is that, let's say there is a transaction that needs to happen between two people. Let's say I have to pay a certain amount of money to another person. So what happens is that first of all, I will go to the system and I will initiate the transaction. I will initiate the transaction. Suppose I had to pay rupees 5,000. So I will initiate the transaction of rupees 5,000 from my end. Now in this case, as soon as I initiate the transaction, there are a number of computer systems, or there are a number of users who will come into the picture now. That's why we are saying that this is a decentralized system, that you are your own bank. There is no centralized bank which is regulating all the transactions. Alright. Normally what happens, that if let's say you have to make a transaction, you will first go to your bank, right? You will first go to your bank, or let's say you have an app or net banking system, whatever you have, you'll have to go to that bank, submit the money there, and that bank will further transact that money for you. Correct? So through this centralized bank, the transaction is happening. So either it will be any private bank or public bank, but there is a central authority in the name of a bank. But in this case of transaction which is happening through a blockchain, there is no centralized authority. There is nobody sitting between the end users, between the person who is sending the money and the user who is receiving the money. So there is no central authority as such. That's why we say that it is a decentralized system. Now how come this decentralized system can be implemented? If there is nobody, a central figure who is responsible for this kind of a transaction, then is it not that this can become a very problematic situation? The answer is no. Why? Because there is a decentralized system that has been built, that there are a network of computers. All these network of computers are called as nodes. Alright. So as soon as the transaction is initiated, this information will be sent to all the nodes that are there in this given network. And all these nodes will now start to verify the transaction. Alright. They will start to verify the transaction. Now why would they verify? What is the gain that they are getting? The gain is that there is a small amount of fee that you are paying along with the transaction, and this small amount of fees will be paid to whoever is able to validate your transaction. So that's why they would want to validate the transaction, because whoever gets to validate, whoever is the first one to validate, that particular user or that particular node will be rewarded. Alright, so this fees that you have paid along with the transaction, this fees will be paid to the person or whoever is the user. Now, one thing which is very important here is that all the users here are anonymous. They might be using a pseudonym, but all these users are anonymous. So there is no control over the identity of all the users who are there in this system. So you initiated a transaction, there is a system or there is a network of computers, and in this network there are n number of nodes. All these nodes are basically users whom you do not know about. You do not know who these people are. You do not know who these networks, what these networks are. So that's why this decentralized system will be an anonymous system. All right. Even the end users are also anonymous. All the nodes also are anonymous. So everything works in a very trustless manner. That's why we say that this is a trustless system. We say that this is a trustless system. Why do we say so? Mainly because you do not need to know the identity of the people, because everyone is working for a reward or everyone is working for their own gains, and that's why they will work accordingly. They know that all the nodes know that if they are validating a transaction, they are going to get rewarded for it. So because there is a reward, they will work for it. So that's why this is what happens here, that it becomes a trustless system. So what has happened is that you have initiated the transaction. So a user will initiate the transaction. A block representing the transaction is created. All right. So this information or this transaction is loaded inside a box. All right, a block, and this block now gets added to the chain. So that's why it forms a blockchain. Now what happens is that this block is broadcasted to all the nodes of the network. All right, all the nodes of the network, and the nodes will validate the block and the transaction. So as soon as the validation is done, whoever was able to validate the transaction will get paid for it, will be rewarded for it. So let's say if it is a Bitcoin, let's say it is a transaction of Bitcoins, then in that case, in case of Bitcoins, whoever is able to validate the block or whoever is able to mine the block, they get 25 Bitcoins. They get 25 Bitcoins. So in this case, what happens is they are rewarded, and that's why they will try very hard to validate the transaction. So as soon as the validation is done, the block is added to the chain, and then the transaction gets verified and executed. Then after that, let's say there is another user who will come forward with another transaction request. The same process will happen again, and then the second block will also be get added to the chain. So in this case, what happens is a blockchain is created. Now it is impossible to take out a block from between. So let's say there are three transactions which have happened one after the other. It's not possible for you to pull out one of the transactions from the three transactions. And this is where you can say that, or in a very similar manner, it works to how a email chain would work. What happens in an email chain? That let's say there are 5 users to whom you send an email, correct? Then after that, there is second user who replies to everyone on the same email chain. Then there is the third user who replies to the same email chain. Then after that, let's say the first user again replies to the same email chain. So now what has happened, that there is a chain of 4 emails that have been created, correct? Now if let's say the second user wants to delete their own email, that's not possible. They can't do that, because a copy of this email chain is present with each one of the users. Everyone who was sent that email, everyone has the transaction history, or everyone has the history of the email chain. So that's why even if you delete the email chain, does not mean that email will be deleted with everyone, correct? So that's why here, once you have initiated the chain, once you have replied to the chain, you cannot change anything about it. Something similar happens here as well, that once the transaction has happened, once a block has been added to the blockchain, you cannot simply just remove the block out of the blockchain. That cannot be done. And if you have to do that, you will have to change a lot of things. So this is where the concept of mining comes into the picture. Concept of mining and concept of the address that is provided, which is called as the hash. So we have to understand what is the meaning of mining and what is the meaning of creating a hash, which is just like nothing but an address for the block. This is nothing but the address for the block. Now to understand the meaning of mining and what is the meaning of hash, etc., let's try to go back to the same example, that there is one user who has initiated the transaction. Alright. So as soon as the transaction is initiated, all the nodes who are there, all these nodes, they will be activated. So this has been, the transaction has been broadcasted to all the nodes. The transaction has been broadcasted to all the nodes. Now these nodes will start mining for the block. Alright, they will start mining for the block. Now this mining is nothing but the validation of the transaction that they have to do. Alright, now this mining process is not easy for them, because what happens is that they have to come up with a number. Alright, they have to basically solve a complex mathematical problem. We say that they have to solve a complex mathematical problem. Now what is the meaning of this complex mathematical problem? Now it's not that they have to solve an equation or they have to do an arithmetic or they have to be very good in mathematics. There's nothing like that. When we talk about this solving of complex mathematical problem, it simply means that they have to correctly guess the hash. Alright, this basically means that they have to correctly guess the hash. What is hash? Hash basically is the address of the block. So every block basically has an address. Every block that is added to the blockchain has an address. So when it comes to mining, all these nodes, when they start mining, what they have to do is that they have to correctly guess the hash, a number which is equal to the hash or lower than the hash. Now equal to or lower than the hash is also a very tricky situation. Just consider this, alright? Just consider this part. It's just like gambling. What happens here is nothing but gambling. That, let's say the hash on the number or the address on the block is 20. So all these nodes who are there, all these nodes have to guess this number, that is 20. Now, either 20 or a number which is lesser than 20. So what happens is, let's say there are 5 users here. There are 5 nodes here. Suppose there are 5 nodes, alright? And these 5 nodes are A, B, C, D and E. Now A guesses, let's say 21, B guesses 42, C guesses, let's say 30, D guesses 16 and E guesses 18. These are the 5 users. These are the 5 nodes who are trying to mine for this particular block. They have guessed these 5 numbers. Now, what happens here is that none of the 5 users have guessed the number correctly, right? Nobody has guessed 20. But there are 2 users who have guessed a number which is lesser than 20. There are 2 users who have guessed a number which is lesser than 20, and out of these the closest one is 18. So what happens is that E is the one who has validated the transaction. E, this is the node, this is the miner who has correctly mined this particular block. So whatever was the user fee that you were paying, this user fee goes to E. Alright, remember, it does not go to A. The closest one is A, but A has a number which is more than the original number. So that's why A will not get that reward. Who will get the reward? E will get the reward. Why? Because E has the closest smaller or equal to number which is close to the hash. If let's say there was another user F who would have guessed 20 correctly, then the reward would have gone to F. But because there is nobody who has been able to guess the number correctly, that's why it goes to the user who has the closest smaller number as compared to the hash. That's why A will not get the reward, E will get the reward. Understood? So this reward goes to E. So E is the one who has correctly mined this particular block. So as soon as mining of this block has happened, validation of the block has happened, and this block now gets added to the blockchain. So it contains a hash. And this hash basically that we are talking about, this hash guessing that has happened, this is nothing but a 64 digit hexadecimal number. 64 digit hexadecimal number. So this has been guessed by the miner. So who are the miners? Miners are the people or the users who are there as nodes in a given network who are trying to guess the correct hash of the block. This is the complex mathematical problem that we are talking about. So that's why it's not an equation or an arithmetic that they have to solve, but rather they have to guess this. Now guessing this number is very, very difficult. That's why I'm saying that this is like gambling. That, and this gambling is not easy, because if you, let's say if you have a dice, then this dice does not have just 6 different sides, but rather it has 1000 sides, and you have to keep guessing, you have to keep rolling the dice to finally arrive at the correct number. So you will keep guessing, you will keep guessing, you do not know what the number is. You cannot start with 1, because if you start with 1, there is somebody who has started with 15, they will be the one to get to the number correctly, right? They will get to the number correctly before you get to the number if it was 20. So that's why you do not know what the number is, so you do not know where to start with. So that's why you might take a lot of time, and by that time somebody else would have mined and validated that transaction. So that's why it's just like gambling, where you have to keep guessing. Sometimes your guess may be correct within a minute, sometimes it would take 30 minutes for you to guess the correct number. By that time somebody else would have done it. So that's why this becomes an entirely different process. Now look at this. What happens is that although this number 20 that I took as an example looks to be very simple to mine, but this is what happens. That if I'm talking about a hash, I'm talking about a 64 digit number, right? I'm talking about a 64 digit number. So let's say for hello world, the hash is this A9489 dot 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 something like this, a 64 digit number. If let's say instead of hello world it was hello world E, then in that case, as you can see, the hash completely changes. If it is hello world C, it completely changes again. So that's why correctly guessing the output according to the input is almost impossible. So that's why it's not something which is very simple for all the miners who are there in the system. It becomes a very difficult task for them to actually come to the correct conclusion, come to the correct number, or at least a number which is very close and it is just about or maybe just smaller than the actual hash. So that's why this is the hash basically that we are talking about. This is what? This is the hash. So every block will have hashes like this. So that's why just imagine that for somebody to crack this hash, to hack into the system, to also guess every other miner, know every other miner who is there in the system, and everyone will have to coordinate. All the miners will have to coordinate with this person who is trying to hack into the system. So that's why it becomes very, very difficult for somebody to hack into a public blockchain. So that's why there are two types of blockchains normally. One which is a public blockchain and the other one which is a private blockchain. Alright. So public blockchain is where this kind of hashing will be required, which will be an open decentralized distributed system. Whereas when you talk about a private blockchain, this is where at least a central authority will be there. There will be a central authority who will at least authorize who can be the users in a given blockchain. So that's why when you talk about things like Bitcoin or Ethereum, these are public blockchains. All right, these are public blockchains, but there can be private blockchains also. For example, let's say if you talk about a logistics company, then a logistics company will not just allow anyone to be a part of their blockchain, correct? Only the users who are associated with that company, only they will be the ones to be allowed to use the blockchain. So that's why there can be a kind of centralized authority in certain cases. Now what happens is, in this entire system where we are trying to build a decentralized, immutable, distributed system, anonymous system, where you can be very sure of the transactions, that nothing is happening to your transactions and they are very secure. So this is overall how the entire process of hashing or mining works, and this is now how the blockchain entirely would work in a distributed open system. So what are the properties or what are the advantages that will have? First of all, it is programmable. That is, according to your requirement of the blockchain, you can create blockchains. So that's why there are cryptocurrencies which are using blockchains. There are private companies in the healthcare sector which are using blockchain. There are many logistics companies which are using blockchain. It can be used to create smart contracts where you do not need a centralizing figure to validate a contract, but rather if the conditions of the contract are being met, then in that case the system itself will clear the contract. So that's why it can be programmable, that you can actually create different types of blockchains depending on your needs. Then it is secure because they are individually encrypted. One of the reasons why hash is required is to make it secure, that because it's a 64 digit hexadecimal number, it's not easy for somebody to just hack into the system and create their own system, because each hash, all right, each hash also has a, a property that this address is a continuation of the previous address. So if one address has been created for a block, it is also dependent on the previous or wherever it is being added. So that's why what happens is, after one there is two, after two there is three, after three there is four. So if somebody takes away two, then it becomes 134, and you will know that something is missing from the system, because then the new hashes that will be generated, they will be completely different. So that's why if somebody tries to hack into the system, it becomes very easy for all the other users in the system to know that there is somebody who is trying to hack into the system, and that user will completely be ignored, because all the others will be working on a similar line. This hacker will be working on some different line. So that's why it becomes very secured, because of the hashing, which also takes all the address one by one, so that nobody can hack into the system. Just think of that email that we took as an example, that once there are 5 users who have replied to that email, nobody can simply just remove one of the replies to that email, because it has created a record of all the email replies one after the other. So that's why this hashing also helps in creating a very secure system. Then it is anonymous. As we discussed, that all the nodes are anonymous, all the users are anonymous. So that's why it's not that somebody will face another problem with somebody else, because nobody knows who the other users are. They are using either pseudonames, or they are using completely different usernames, where there will be no problem with the identification, or nobody will be identified as a user. So that's why it again makes it a lot more easier for somebody to work on that system. Then after anonymous, it is also unanimous, because all the network participants agree to the validation of each and every record. That as soon as somebody, let's say, as I said, that this is a gambling table, that there are 3 people who are rolling their dice. All of a sudden, there is somebody who got the number correctly. So others will say, okay, okay, you got it. So this round of the Bitcoin goes to you. So just like a gambling, what will happen in a gambling situation? That others will say that, okay, okay, this round you are the winner. So something similar is happening here as well. So that's why this becomes a unanimous system. Then we already discussed this, that this is also a distributed system, that every participant has a copy of the ledger. Just again, as we discussed in the example of that email, that even if you try to delete the email from your system, the others already have the copy of that email, correct? So that's why it is a distributed system, and nobody can simply tamper with the entire system. Then one very very important part, as we discussed initially, that it is immutable, meaning that all the validated records are irreversible and cannot be changed. Again, the same example comes here, that you cannot simply change the entire setup. One after the other, the information will be added. So for example, let's say instead of paying 5,000, as I had taken the example initially, instead of paying 5,000, let's say I paid 7,000 by mistake. Then in that case, I cannot do anything. I cannot reverse the transaction now. It is up to the other user who has received surplus amount to return back 2,000 to me. So that user will have to initiate another transaction of rupees 2,000 in the same network, so that now the balance amount, the extra balance amount that I had paid by mistake, can be returned back to me. but it is up to that user. If that user does not want to pay back, I can't do anything. So I cannot be the one to reverse the transaction. So that's why once a block has been created in the chain, it cannot be taken back. It cannot be taken out. So that's why this is what immutability is. One of the most important, one of the central themes of blockchain. Two important things, always remember. Decentralization, immutability. These two are the most important properties of a distributed ledger system or a blockchain. Then timestamp. All the transactions are timestamped. When the transaction happened, this becomes a part of the hash. This becomes a part of the hash. So all the hashes or all the addresses, apart from the fact that they keep the information, they keep the address of the previous block, they also keep a track of the transaction history. They keep a track of when the transaction had happened. So that's why this also becomes a very, very important property. So that's why all these properties together make blockchain a very unique system. That how we look at blockchain today. Right now in cryptocurrencies, we are using blockchain, and at other areas, other applications, in a very limited form, we are using it. How the researchers, the scientists, the people from the technical background, how they define blockchain today is how they used to define internet in the 1990s. That it is something that is going to change the world, completely change the scenario, how the world looks at technology, and look at what happened in the last decade or so with the help of internet. So something similar they assume will happen with blockchain also. That today it is a very limited technology being used in a very limited manner, but in the coming days perhaps it will completely change the way we look at things altogether. Now, what are the disadvantages of blockchain? What are the problems? There is this term that you should know here called as trilemma. Instead of dilemma, the word trilemma is used in the technical sense in case of blockchain. So when we talk about the disadvantages, this trilemma becomes very, very important. What is this trilemma? First, decentralization, scalability, and security. These are the three major concerns that blockchain technology has. What are these three problems? One, decentralization. Now, decentralization we say is an advantage with blockchain, right? But at the same time, it also becomes a disadvantage. Why? Because it is a decentralized system. It also means that as soon as you initiate the transaction, it goes to every node, correct? And all these nodes will now start mining for this transaction. So this takes some time. It takes some time for this transaction to be validated. So because of this decentralization, what also happens is that this entire system becomes a slow system. This entire system becomes a slow system because of this decentralization. For instance, if you look at an example, if I talk about a Bitcoin, all right, it takes all, we have seen that normally 7 transactions per second can be done. In case of Ethereum, it has been seen that almost 30 transactions per second can happen. But in case of a centralized system, for example, let's say if you are talking about a credit card transaction, then in case of a credit card transaction, almost 5,000 transactions per second can be done. So just look at the difference between a decentralized system and a centralized system, correct? Because these two are what? These two are decentralized system. These two are decentralized system and this is a centralized system. Correct. So that's why what we are looking at is that a decentralized system is much slower as compared to a centralized system. So this is one big challenge as well. Although it provides a lot of security and makes it a very unique system, a trustless system as we say, but at the same time it also makes it a slow system. Then after that, the other problem is this problem of scalability. Now what is the problem of scalability? We are looking at ever increasing number of cryptocurrencies, ever increasing number of blockchains. Now all these blockchains have to be stored, correct? Storage can become a big challenge because we are saying that all the transactional history is there in the blockchain. It's not that after 3 transactions the first transaction is being deleted. right? That's not happening. So all the transactions are being stored. All the transactions that have ever happened are being stored. So that's why scalability in the coming future can become a challenge, because you will need so much of storage space to store all the information, to store all the cryptocurrencies or all the blockchains at a place. So that's why storage or scalability can become a big challenge. Now, to overcome the problem of decentralization and scalability, many of the firms, especially the private blockchains, they compromise on the two. They compromise on decentralization and scalability so that they can provide a faster method, or a faster blockchain technology. So when they do that, they also compromise on security. They compromise on the security because now many of the users will be known, many of the users will be planted accordingly, according to the requirement, and that's why it becomes a less secured system as compared to what a normal open decentralized distributed blockchain would be. So that's why these three problems together are called as trilemma of bitcoins, or trilemma of blockchain in today's world. So disadvantages, other disadvantages are that it is extremely volatile, that we see that the cost or the value of blockchains keep on decreasing or increasing. So that's why it becomes very volatile. Then there is a transaction cost. As I told you that initially when you initiate the transaction, you also have to pay a small fee, and this small fee goes to whoever is able to mine or whoever is able to validate your transaction. Then uses excessive energy. This is a major disadvantage, that because of the mining that needs to be done, all the computation that needs to be done with the help of ASICs, a kind of computers or the systems that are used by the miners, all the power that they use because they have to keep computing all the time, it also wastes a lot of energy. For example, one of the reports have said that the amount of energy that bitcoins use today is more than the total amount of energy that will be consumed by a small European country. So just imagine that a small European country, the amount of power that they would be using, compared to that, bitcoins today use more power because of the mining activities that have to happen. So that's why energy usage is huge. That becomes another challenge. So what will happen initially is that it may increase the use of fossil fuels, increase the use of fossil fuels because of the mining activities. Then complexity. There are so many things that I have told you. Perhaps you will also have to go back and revise it a couple of times to understand what has been happening in the blockchains and how blockchains are being implemented. So complexity in the system is there, and that's why it's not easy to understand the entire system, how the system works. Whatever I have touched is just the surface of the entire working of the blockchains. And then storage, which is again a problem associated with the scalability, that as we start increasing the amount of bitcoins being used, or any cryptocurrency for that matter being used, and again blockchain being implemented to different arenas and different application areas, we don't know how much of storage space will be required in the future. So that's why that's another disadvantage that we see with blockchain. Now have a look at this question that was asked in your prelims examination. With reference to bitcoins sometimes seen in the news, which of the following statements is or are correct? One, bitcoins are tracked by central banks of the countries. Completely wrong. That's why we are saying that this is a decentralized distributed system and there is no central authority. All the users are also anonymous. So that's why these are not tracked. All these transactions are not tracked at all. Then anyone with a Bitcoin address can send and receive Bitcoins from anyone else with a Bitcoin address. This is true. This is what happens, that everyone has a public and a private key. And this public and the private key also becomes a part of the transaction, and whoever is at the other end will identify the key and the transaction will be done. So that's why this is correct. Online payments can be sent without either side knowing the identity of the other. This is again true. We discussed about this, that all the users are anonymous. Whoever is sending and receiving, they are using pseudonames or usernames. So that's why you do not know the exact identity of the person on the other side. So that's why this is also correct. So that's why the correct answer here will be 2 and 3 only.